Assalamualaikum students. My name is Hiranam. Today's our topic is matrix. Matrix is very important topic in mathematics. So firstly we introduce matrices, type of matrices, operation of matrix, determinant, inverse of matrix, solution of linear equation. Matrix. What is matrix? A set of numbers arranged in rows and columns in the form of rectangular array. The number is called elements and entries of the matrix, and matrix have wide application in engineering, physics, economics, in many fields. Matrix has many applications in real life, or I say world. You can see this is a set which is arranged in row, arranged in column. A and B is a row because it is horizontal, but AC is a column. It is vertical. AC is one column and BD is second column. Similarly, AB is row 1 and CD is row 2. Here you can see 3 columns and 3 rows. You can see 3 columns, 1, 2, 3. 3 rows, 1, 2, 3. You can see this is 1 row and 1 column. Here you can see 3 columns and 3 rows. You can write here 3 cross 3. You write firstly M, which is M cross N. M denotes rows, N denotes column. You can see this is 2 cross 2. Firstly you write rows 1, 2, 2, columns 1, 2, 2. This is also changed. You can write in 1 cross 2, 2 cross 1. Order will be changed with the matrix changes. You can see this is column, this is rows, and M cross N. Here M1 row 1 and column 1, M1 row 1, N2 column 2, M2 N1, then it become row 2 column 1. This is according to the orders of rows and columns. This enters depending on this. Types of matrices or matrix: row matrix, column matrix, zero matrix, rectangular matrix, square matrix, diagonal matrix, identity matrix, inverse matrix, upper triangle matrix, lower triangle matrix. Type of matrix. These are the types of matrices. Row matrix. In this one row you can see, but columns are, you can see 1 row, 1, 2, 3. Here you have 3 columns, 1 cross 3, but you can see only 1 row. This is 1, 2 columns but 1 row. When you write a matrix in just 1 row, then it is called row matrix. You can write here A 1 cross N. N will be changed, but M always be 1 in row matrix. Similarly, column matrix, here we have one column but different rows. You can see 1 2 1 2 3 1 2 3 4 5 6. In this you can write m cross 1, n equals to 1 always. In row will be 1 and many columns it will be 1 or many, then it is called row matrix. When column will be 1 and rows 1 and more than 1, then it is column matrix. But in column matrix, 1 column. Zero matrix, entries will be zero matrix, also called null matrix. In this, all entries are 0. Entries or element, you can see entries or element will be equal. This is 1 cross 1, this is 2 cross 2, this is 3 cross 3, but you can see entries will be 0. All entries are 0. So this is zero matrix or null matrix. Rectangular matrix. In this, your row and column will not be equal. Then it is called rectangular. In this you can see 2 cross 3, 3 cross 2, and you can see this 1 2 3 4 5. So it becomes 2 cross 5 or many. Here you can rows, number of rows does not equals to numbers of column. This is called rectangular matrix. In square matrix, number of rows equals to the number of columns. You can see 2 cross 2, 3 cross 3, 1 cross 1, 4 cross 1, 4 cross 4, 5 cross 5. This is equal. You can see these are equal. M equals to n. Then it is called square matrix. Diagonal matrix. In diagonal matrix, entries of diagonal elements will be changed, but other entries are 0. You can say this entry is 1 3 9, but other entries will be 0. You can see this 4 cross 4. You can see this entries of diagonal. Here is the diagonal. So this diagonal entries are 1 4 7 10, but other entries will be 0. Above or below, all entries are 0. Identity elements. Identity matrix. Same as identity elements, we multiply n with 1, it is equals to 1. This is identity, we do not change this. Similarly, we have identity matrix. In this, we have identity in this form or this form. Diagonal elements will be 1, but at the above values and below values of diagonal elements will be 0. These entries will be 1, other entries will be 0. In 4 cross 4, it will 1 here and 0 0 0 0 0 0. So only diagonal elements have one values. Other elements which above the diagonal line is 0 or below the diagonal line is 0. Inverse. Similarly, we have 5 multiply with 1 over 5, which is inverse of 5, or say 2 minus 2, inverse of this. These kinds of inverse. Similarly, in matrices we have inverse A, their inverse is -1, their inverse is A. Upper triangle matrix. Upper triangle matrices में in upper triangle matrix diagonal entries and above diagonal entries will be non-zero, or you say any entries, any number, but below values are 0. In upper triangle, diagonal elements and above the diagonal elements are not 0, but below the entries are 0. In lower triangle matrices, diagonal and lower diagonal elements are non-zero, but it is above values are 0. You can also say that here you put 0 or here you can put 0, but mostly these three have values. These three entries also have values, not all 0. If all 0 become diagonal matrix. Singleton matrices. In singleton matrix, one element have. You can see this C equals to matrix 2, D equals to 5, matrix 5, or E equals to matrix 0, or any number. This is called one element singleton matrices. 1 cross 1. Operation of matrices. Addition. In addition, you can have two matrices or more than two matrices. They are of same orders. You can see 2 cross 2 and 2 cross 2. Then you add first element with the first element, second entry with second element. Second row of first element will be second row of first entry. Second row of second element will be add with second row second element. Or you can write their orders 1 cross 1 plus B 1 1, A 1 2 plus B 1 2, A 2 1 plus B 2 1, A 2 2 plus B 2 2. Then answer will be this. You can add B plus A or A plus B. This is equal, so this is commutative matrices. Consider the following matrices. You can see this and this order is changed, so this is not, we make sum on this, so this is not possible, order is not same. But you can see F and G are same order. Then you can add minus 2 plus 2, 1 plus 3, 3 plus minus 2, 2 plus 7, 5 plus 3, 6 plus 1. It becomes 0 4 1 9 8 7. If any matrix A is added to the 0 matrix of the same size, the result clearly equal to A. You can see this 2 cross 2 and 2 cross 2 matrix of 0 or null matrix. Then answer will be 1 plus 0, 5 plus 0, 5 plus 0, 9 plus 0, it is equals to A. Similarly, subtract. Consider the following matrix. Order will be changed, so F minus D is thus not possible, but F minus G will be possible, and you do this. Scalar matrix. In scalar matrices, A equals to A mn is the matrix and K is the scalar, then Ka equals to Ka mn. If any scalar is the magnitude or number, it will multiply with any matrices like 2. Here we are taking 2, 2 multiply with this, 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 2 multiply with this. This is the change. Or you can put 3a, find 3a, then it will be 3 multiply 1 is 3, 3 multiply 3 is 9, 3 multiply 5 is 15, 3 multiply 7 is 21, 3 multiply 8 is 24, 3 multiply 9 is, so you can find 3a. In scalar multiply, you multiply a number with matrices. Now you can easily see this. Or you can take again common, taking 3 common and from a, so you can similarly taking common from this. Product of matrices, you can product m cross n and n cross k. N will be cancelled, m n means here we are taking from row and here we are taking from column. So this is m cross k. You can see this 2 1 4 0 1 4, and this is the matrix 3 cross 3 2 cross 3. Then you make matrices, order of column, order of rows. First matrix of order of columns will be same of second matrices of column. If they are not equal, then matrices will not be multiplied. These are same, then it multiply, otherwise it will not multiply. You can see this, these are 3 columns and these are 3 rows, so these are similar, so result will be 2 cross 4. You can multiply 2 multiply 6 plus 2 multiply with 1, 1 multiply 1, 4 multiply with minus 2, it become this. You can write other with this column, it will become 2 cross 3 is this, plus 1 multiply with 1, it is 1, plus 4 multiply with 5 is 20. Now 2 multiply 0 is 0, 1 multiply with 4 is 4, 4 multiply with 2 is 8. This row here, you can, I missed the column, 2 multiply with minus 1, it become minus 2, 1 multiply with 0 is 0, 4 multiply 0 is 0. So you multiply this, it become 12 plus 1, it become 13, 13 minus 8, it become 5, which is equals to 5, and this is 6, 6 1 7, and it is equals to 27, and this is minus 2 and this is 12. Then 0 multiply with this, it become 0 multiply 1, 0 multiply 1 is 1, plus 1 multiply with minus 2, it become minus 2. So our answer is minus 1. So 0 multiply 3 is 0, 1 multiply is 1, 1, plus 1 multiply with 5 is 5, answer will be 6. 0 multiply with minus 1 is 0, 1 multiply 0 is 0, is 0, then this is 0. This multiply with 0 is 0, plus 1 multiplied with 4 is 4, and 1 multiplied with 2 is 2, which is equal to 6. Our answer becomes 5, 27 minus 2, 12, this is 6, this is 0, this is 6, this is minus 1. You can see this again. $3 multiplied with 13, $4 will multiply with 8, $2 multiply with 6. It becomes $83. Similarly, $3 multiply with 9, $4 multiply with 7, $2 multiply with 4. Answer will be $63. Similarly, $3 multiply with 7, $4 multiply with 4, $2 multiply with 0. Answer will be 37. $3 multiply with 15, $4 multiply with 6, $2 multiply with 3, which is equal to 75. You can see this 1 cross 3. This is equal to 3 cross 3. Answer will be 1 cross, 1, 2, 3, and 3 cross 4. Answer will be 1 cross 4. You can see this. Also, A multiply with G, B multiply with H. Answer will be A cross G plus BH, C multiply with G plus DH, E multiply G plus FH. You can see this 1, 2, 3, 3 cross 2, and you see this, it is equal to 1, 2, 2 cross 1. Answer will be 3 cross 1. You can see this. Three, 2, 1, 5, 9, 1, 4, 3, 0. You have these numbers, entries, different entries, and you have two matrices. One is this and this. You make product 3 multiply with 2, 2 multiply with 1, 1 multiply with 2, 5 multiply with 8. Answer will be 50. Similarly, you can do this. This will multiply with this will multiply with this, and this, then this multiply with this, then this multiply with this, and you find the last answer of product. A multiply B. Similarly, 1, 2, 3, 4, 5, 6, 7, 8. Multiply 1 with 5, 2 with 7, 3 with 5 plus 4 multiply with 7. Now 1 multiply with 6, 2 multiply with 8, 3 multiply with 6 plus 4 multiplies 8. Answer will be this. You have A multiply B. A is this and B is this. 2 multiply with 1, 0 multiply with 3, 1 multiply with 2. You can see this. Then 2 multiply with 0, 0 multiply with minus 2, 1 multiply with 4. You can see this. 2 multiply with 1, 1 multiply with 3, 3 multiply with 2. You can see. 2 multiply with 0, 1 multiply with minus 2, 3 multiply with 4. Answer will be this. B, A. 1, 2, 3, 1, 0, 1. 1 multiply with 3, 2 multiply with 0. You can see this here. This is first value. Then 1 multiply with 1, 2 multiply with 1, this value. Answer will be this. This is 1, 2, 1 cross 2, and this is 2 cross 2. Answer will be in 1 cross 2. You can see no m cross n cross k. Answer will be in m cross k. Transpose of matrices. Transpose of matrices is very simple thing. In this, column become row and row become column. Like you have 1 3, a equals to 1 3, and second row is 1 6, 1 6, 1 row and second row. It become 1 3 in column, 1 6 in column. Or you can see this 1 column, 1 row, 2 column, 1 row, 2 row, 3 row. 1 2 become 1 column, 6 4 become second column, 7 8 become third column. Row will be changed in columns. Row will change in column and column will change in row. Symmetric matrix and skew symmetric matrices. In this symmetric matrix, A transpose equals to A, and skew symmetric is A transpose equals to minus A. You can see this 1 1 minus 1 2 1 2 0 minus 1 0 5, and this symmetric matrix is when A equals to A transpose. When you make transpose of this, it become 3 2 11 5. Just a minute. You are taking transpose of this matrix 3 2 11 and last 5. Now 2 9 minus 1 6, 2 9 minus 1 6. You can see this 11 minus 1 0 7, 11 minus 1 0 7, 5 6 7 9, 5 6 7 9. This is equal. Transpose and matrices is equal. Then it is called symmetric matrices. This is also symmetric matrices. You can take the transpose of this, which is equal to the matrices. Symmetric matrices. Skew symmetric. In skew symmetric, transpose will be in minus A. When you take transpose, then you need to take common from it. Then it becomes equals to A. If you can see this, we're taking transpose of this, it becomes 0 minus 2 minus 3. Second is 2 0 minus 4, 2 0 minus 4, 3 4 0, 3 4 0. It is not equals to 0, so we need to take common. If we take common, it becomes equals to A. 2 3 minus 2, because we are taking common from this also, 0 minus 4 become 4, positive 3 become minus 3, minus 4 and 0. This is equals to minus A. It is this type of matrices is called skew symmetric matrices. You can see this another example. You have one matrix is taking transpose, then it is equals to minus A. you have another example. Determinant. We need to talk about determinants. A matrix of array of numbers and matrices. This determinant, you can find 2 cross 2 easily. This multiply with this and minus this multiply with this. You can multiply this and this. You can write here a multiply 1 1, a multiply 2 2, minus a multiply 1 2, a multiply 2 1. You can see this in 2 cross 2. You can use this. 3 multiply 6 is 18, minus 8 multiply 4 is 32, and determinant is minus 14. Symbol of determinant is mod. This is mod, 2 straight lines, or you can use it. You can multiply a multiply with d minus c multiply with b. 2 cross 2, AD minus BC. Blue line is positive and red lines are negative. You can see this determinant. 1 multiply with 4 is 4. 3 multiply 2 is 6. Before this you can write sign minus 6. Answer is minus 2. In 3 cross 3 you can write A, then you ignore this row and this row. This row and this column. You are taking A, so you ignore column and row. Multiply E with I minus multiply H with F, like this. Then you write minus of the formula. Then before this we raise these lines, then you easily understand. Now you take B, you ignore this row and ignore this column. You multiply D with I minus G with F, like this. Then add sum of formula. Before this you raise these lines. C, ignore this row and column. G multiply with D multiply with H minus G multiply with E. Similarly C, when you do C, ignore this row and column. D multiply with H minus G multiply with E, like this. You can see this C, you are taking determinant of 3 cross 3. 6, ignore this row and column. You can ignore this. It becomes minus 2 multiply 7 is minus 14. Minus 14 minus formula. Then using sign of formula, then 8 multiply 5 is 40, which become minus 14 minus 40, which is equal to minus 54. Then you are taking 1, ignore this column and ignore this row. Ignore this row and this column. 1 will multiply with 4 multiply 7 is 28 minus, before this you are using minus of formula. 4 multiply with 7 is 28 minus 2 multiply with 5, which is 10, which become 18, minus 18. Now you are taking 1, ignore this line and this. ignore column and row, it become 1. Before you this using plus, which is the sign of the formula, it become this. Ignore this and this. 1 multiply with 4 multiply 8, which is equals to 32. Minus 2 multiply with minus 2, which become minus 4. It become 36. Then you multiply and simplify. If you take 4, then you are taking like this. You take A and 3 cross 3 column matrices, then B 3 cross 3, then C 3 cross 3, and 4 D 3 cross 3 matrices. Ignore their rows and columns. Ignore their rows and columns. Only take that element. Like this, you can multiply with the element which you have taken and ignore other entries of the rows and columns. Consider the determinant equals to this, and then determinant of minor m is this. Minor a equals to, when you take minor means you are taking 1 minor, means you ignore these rows and columns and you are taking multiply this and this. You are taking this, you can see this entries will be this. A22 multiply with A33, A32, A23, or you can write this. This is determinant, and you easily determine this value. This is similarly 2 cross 2, it is easy to understand. Then you are taking 1, 2, then take this and ignore row and column. It become A21, A31, A23, A33, like this. A13, similarly you are taking this and ignore their row and column. It become A21, A22, A31, A32. Minor of 3 cross 3. You can similarly take this column, this entry, ignore this row, and for this I remove these lines and easily to understand for you. Now you take this entry A21, then ignore their row and column. Ignore their row and column. It become A12, A13, A32, A33. Similarly, A22, ignore this row, ignore this column, then A11, A13, A31, A33. Then taking A23 and ignore this row and column, it become A11, A12, A31, A32. Then you are taking other, which is equal to A31, then it ignore the row and column, it become A12, A13, A22, A33. Then taking this, it become A11, A21, A13, A23. Similarly for this pattern, this is called minor. When you taking minor of this 3 cross 3, then it is, you can find this. Then you do not multiply with their constant value, only find the minor. You can see this, it is easy to understand. This is 3 cross 3 and this is finding 1 cross 1. E multiply I minus H multiply with F. In down 1 minor of 1 2, it multiply D with I, G with F. 1 3, D multiply with H, G multiply E. Similarly on previous pattern. You can easily understand we are using the same method for the minor. 3 cross 3. Calculate the minor. Similarly, we are finding minor of this. You can write these things. In 3 cross 3 you can find minor. Then you know this. Finding minor of m11, which is equals to 2, 4, 2, minus 1, minus 2. When you find m2, it is equals to 0, 2, 1, minus 2. Minus 3, 1, 3, then it is equals to 0, 4, 1, minus 1. When it is finding for 2, 1, it becomes minus 1, 3, minus 1, 2. When it is equals to 2, 2, it becomes 2, 3, 1, minus 2. In similar pattern, you can find these minus 2 and minor of 2 cross 2. Minus of m11. When you find 2 cross 2 minor, then it is equals to 1, 1 equals to D, 1, 2 equals to C, 2, 1 equals to B, 2, 2 equals to A. Cofactors. In cofactors, you will find minor and multiply with minus 1. Power is their order. When you find minor of 2 cross 2, then it will be the 2 cross 2, which is positive. If you find 3 cross 2, then it is negative. You can see this like this. You are finding minor for this. A12 minus is minus 3. You are finding A12 minus this minus 46. 1 plus 2 is 3. Power of minus 1 is 3 is minus, which is multiplied with minor, which become positive 46. Similarly, you can find minor and coefficients, adjectives, adjoints of the matrices. Adjoints a matrix of element ij, be a square matrix of order n. Then adjoint of A is transpose of cofactor A. You can see this. You are finding for adjoint, you are finding coefficients. Then you writing this. You know these things. You have minor numbers like 1, 1. You find minus numbers. You can see this. Then multiply with 1, which become cofactors. You have order with orders. You can see this. You have order 1, 2. Putting in the matrix of the same order. This is equals to 1a 1, 1 equals to 3, a 1, 2 equals to minus 4, a 2, 1 equals to 2, 2, 1, which is equals to a 2, 2 equals to 1. This is the cofactors. Then take its transpose. This is become adjoint. You can see this. Write the cofactors in a matrix form. Then take transpose, which is equals to the adjoint of A. This is very simple. Singular matrix. When you take determinant of a matrix, it becomes equals to 0. Then it is called singular matrix. If it is not equals to 0, then it is called non-singular matrices. If you have 0, then inverse will you can see this non-singular matrix example. If determinant is not equals to 0, then it is not singular matrix. For this, you have when you have singular matrix, then inverse will not be half of the inverse does not exist of that matrices. If matrices is not singular, then inverse will be found. You can see this formula of inverse. A inverse equals to adjoint over determinant of, all you know is adjoint is very easy to take and determinant is also. So we are taking matrix P, their determinant is not equals to 0. We find this, then we find inverse of this, then find the inverse of this. First of all, you'll find that determinant which is not equals to 0, then we know this inverse will be exist. Taking minors, taking coefficients, taking inverse transpose of coefficient matrix which is equals to adjoint of A, then divide adjoint of A divided by determinant of A. You can divide with this, it becomes 2 minus 3, 1 minus 2. Determine whether the matrix given below is invertible. So find the invertible matrix of given. You can know easily invertible is also called inverse. So determinant of this is minus 1 which is not equals to 0. So we can find the inverse of this matrix. Find the minus, then find coefficient. Find the cofactors. First of all, find minus, then find cofactors, then take transpose of cofactors matrix, then divide when you take a transpose, it become adjoint of A, then divide with determinant value, it become inverse of A. This is a exercise to solve system of linear equation. In system of linear equation, two linear equation will be must because it is system of linear equation, like this and this. You can write in the matrix form A equals to, you can write coefficient or constant of the variables. In X you can put variables and B write answers or write the right hand side constants here. Then system of equation can be written in matrix form like this. Multiply with this, A multiply with X equals to Y. Then find inverse of, find the X value, then X equals to A inverse B. If right hand side is equals to 0, then system is homogeneous, otherwise it is non-homogeneous. If Y values are 0, then it is homogeneous. If Y values have some entries, then non-homogeneous. In 3 equations you can write this. Algorithm for this: write given system in the form of matrix equation. Find the determinant of matrices. When determinant is not equals to 0, then if determinant equals to 0, then inverse will not be exist. So solution does not exist, so we need inverse will be exist. 5 determinant exists, then inverse exists, then this procedure will be applied. You can see this, these are 2 examples. This is equals to 0, Y values are 0 here, but you can see this minus 9 and 15. These are the constant you take from left to right, then Y entries will be not 0, then so it is non-homogeneous. You can write A is 4, 5, 7, 8 minus 8. You can see this 4, 7, 5 minus 8. X will be xy, B equals to or you can say y equals to or 9 minus 15. Taking determinant of this, which is equals to minus 67. Now you have to find the value of x, so you have to use this x equals to a inverse b. You can see determinant of a is exist, so you take minor values, then you find cofactors, then you take transpose of that matrix. This is adjoint, and divided by determinant value, it is inverse. So inverse is this, it will be multiplied with the b, and we find the value of x and y. First value is x value and second value is y value. You can see this x value is first and y value is second. Similarly, we take the determinant of a, which is not equal to 0, then find minor and cofactors, which is this. Take the transpose of cofactors, which become adjective divided by determinant, which is a inverse, then multiply with b. Then we have to know the value of x, y and z. Here's some references for this lecture. Thank you for watching this video.